Hey, hello friends, and welcome to another video of this series. In this video we are going to see how you have to do the design goal setting. Now, why design goal setting is critical? Let's say you are starting a project or you got a requirement from a company, so you have to be very clear in terms of what you are going to make. So when I say what you are going to make, right, so based on the requirement, lot of things drive. In case whatever you are making, that needs to be a automotive grade or a consumer grade or a industrial grade, so you have to understand what is the end application, where that board is going to be used outdoor, whether there is any sort of a protection required, or what sort of a housing or the enclosure that PCB will be having. So there are a lot of things that you have to put in terms of conceptualization. So if we again go back to what we discussed, right, and what we have been discussing, so in a hardware development cycle, you have this conceptualization, and then you have the BOM selection, pin configuration, schematic capturing, PCB design, then everything follows, right, and then you go for a mass production. Now in case when you get a project, it's very critical you have to have the proper conceptualization, or I can say the proper planning to be done. So if we talk about what we are going to make in this series, right, so already I've shown you in the previous video. So before I go ahead with the video, I would like to thank Altium for sponsoring this video. So this whole series has been done with on the Altium, and you can see like already we have done with the schematic, but in the upcoming videos we'll be going through. So why to choose Altium? Okay, so Altium is one of the best PCB designing tool, and there is a link in the description. If you click on that link, you will be automatically invited to get a free trial of Altium Designer, and you will be eligible for this 25% off on the license purchase. When it comes to why Altium, so Altium offers Altium 365, where basically you can connect all the or connect all the resources in place for your hardware development life cycle. So whatever we are talking over here, right, to have this whole life cycle done till production, the same can be achieved over here when you are working with different teams in an organization. So this is what the hardware requirement is. So we have to design a telematics logger device that features a 4G LTE, GSM, GNSS. So we should have a GPS in place. We have to have BLE or Wi-Fi connectivity along with dual CAN channel. So CAN is controller area network communication channel needs to be there. And since it's a logger device, right, we need a SD card option as well. So if you see the primary use case, logging the data over CAN channel in automotive setup. So whenever it says automotive setup, right, that means whatever the component selection would be, you have to make sure those are all automotive grade. So we'll be coming through that once we start the component selection. Okay, then in terms of other use cases, okay, so it can be used as a location logger since it has the GPS, right, so someone can just use to log the lat long. Let's say if you want to track a vehicle, you want to put this divider on a vehicle and track it. And also it can act as a data transmission unit, or I can say IoT device, where maybe some interfaces are given where you can basically read some sensor data, or something as an input. It can be some emergency switch or anything it can be. So whenever those are getting pressed, or any sensor value that needs to be sent to the server. So if we talk about what all recipe would be, right, so we are talking about something, a GSM modem to be there. We need something to have a Wi-Fi and BLE as an option. And since we need dual CAN, right, we need to have an additional host MCU, which is let's say we can go for ST microcontroller. So in upcoming videos we'll see what all options we'll be having when it comes to the microcontroller. But let's stick to ST microcontroller because as a platform, right, ST micro is very popular. When you go in industry, they have the best MCUs, microcontrollers available. So let's see like how we have to put this design goals now. So if you see, I have basically bucketed everything in terms of whatever in the previous sheet we saw. So let's say input supply. Okay, since this is going to be a telematics project, right, and we want to log the CAN channels. So usually CAN, when if you are aware, right, CAN channel is most common, or I can say it is getting used in automotive where the vehicles are there. So you have cars, you have trucks, everywhere you will have the whole communication network is on CAN. Okay, so typically there you will be having 12 volt or 20 volt auxiliary supplies. And if in case it is EV, let's say a two-wheeler EV, right, there you will have directly power from the traction battery. That means it can be a 48 volt battery system, 72 volt battery system, or even upwards of that. So here we are talking about we need to have at least 12 volts, okay, and 24 volts also can be a system, since this is going to be used as a DTU, okay, data transmission unit, or a logger. So we can think of 24 volt as well. Even it can be used for industry automation and other industries, so it needs to have at least a 24, so that the PLCs and other controller works. So if you talk about all MCUs, right, so whatever we saw in the previous section, we had this ST microcontroller, then the GSM part, everything works around 3.3, 3.8, right? But we have to step down. So your input supply drives in terms of whether you just need a LDO, or you have to have a step down converter, then the LDOs being in place. Okay, so what we can conclude here, right, a wide input voltage range like 9 to 28 volt would provide versatility, making your hardware compatible with both automotive and industrial. Okay, so I think whatever we have to choose, right, in terms of the step down, we have to make sure at least it support till 28 volt, though typically it will be around 24 volt as a nominal input, but this is what the margin you should be having. So you should at least have 25% margin. So let's go back. Okay, so the other one is the size and dimension. So whenever a requirement comes, right, it will come whether what is the size of the PCB it is going to be. So it can be a smaller PCB, or maybe you have a case already. Okay, so you have an enclosure already, around that you have to build that hardware. So everything is getting derived based on how the end application use cases. Okay, so the board size. Okay, so if it is a smaller board you have to make, right, that means it needs to be a multi-layer. You have to make a dual 2-layer or 4-layer boards, or even 6 layers in some times. So this is what derives the board size. And also once you shrink the board size, right, to fit to the application, you have to have the components also selected the same way. So the footprint of the component will change, the package size of all the passives, and even the core component, let's say MCU, right, so MCU comes with a different packages. Okay, so you can go for a BGA package if in case you want a smaller size. And also sometimes mostly, right, this MCU comes with different pin packages. Okay, so based on your requirement, maybe you have to go for a 48 pin, but there is already a 100 pin option available, right? So just as an excitement, you cannot go and select a 100 pin. Based on the application, you have to see what is the optimum MCU that you have to go for. Then as I talked, right, so in case of layer count, it depends, single layer, double layer, multi-layer. Then you have a thermal management. Okay, so PCB when you design, right, so based on the size also, if you have enough room, right, you can route things properly, you can have proper thermal reliefs done. Okay, so it derives a lot of things. When it comes to cost, right, so let's say if you are making a 2-layer PCB, so the cost would be relatively lower than a 4-layer PCB. Okay, and if it is a single layer PCB, even it will be lower. But everything is a derivative of how many components are there on the board, what is the size we are looking for. And then comes the route complexity. So the moment you have a smaller board, the routing might be difficult, because you have to have a 2-layer or a 4-layer or a multi-layer board. So in our case, I think once we start the design, right, once we start routing, mostly what I believe, right, it is going to be a 4-layer board, but we'll see. Okay, so we cannot conclude in terms of the number of layers on the PCB. Since this is an internal requirement, I have taken this as a project to help you guys understand. So I'm flexible, so I can go with any dimension. So I'll be taking an optimal dimension where I will be designing a 4-layer PCB. So let's go back. So we are done with the input supply, we are done with the size and dimension. Let's see the connector. Okay, so if you see, I took this reference from one of the famous CAN logger device, which is very common. And if you see, right, this we have as a DB9 connector, and you will see this sort of a connector being available. Okay, so we are going to use this. Okay, and you can have a OBD connector option also, but we are not using it. Okay, and in terms of interfaces, we can have a type C interface where we can directly flash something over here, and same goes for the GSM part. Then you have a SMA connector for the external antennas. As I told, right, this is going to be automotive setup. That means this hardware needs to be mounted somewhere inside the vehicle, or it can be mounted, you might be having a metal casing. The moment you have that metal casing, you cannot put that antenna inside, right? So you need to have an external attachment done. So we have to go with something like this. Then you have a JTAG connector. So JTAG will be coming in detail. So these are basically the programming pins, how you can go and program. Let's say the express if ESP also can be programmed through JTAG, or the ST microcontroller, you can just put a 10 pin JTAG and program it. Then you can have additional interfaces. There might be a battery connector, or might be some interfaces where you want to expose the UART. Okay, so this is how the whole connector requirement you have to basically do. So here, once you have done, right, you have to put all the list of the parts. Okay, so coming to working environment. So since it's an automotive project, so whatever the parts you will be selecting, right, already that those parts will be supporting close to 150 degrees centigrade. But in case of what I say, right, industrial and other things, you'll typically be seeing something like -40 and goes till 85, even 105 degrees. Okay, then vibration and shock. So let's say if you are considering SMD parts, right, and you want to mount this directly on the chassis of some vehicle, that means you have to have a potting. So what potting is basically, you would have seen, right, there are hardwares where basically some resin material is there, right, so that all the components are basically there is no movement available, right? So there is no air gaps and other things. So you have the solid components around the so a solid part around the component, so that in case of any vibrations and all, there is no room for those components to move. Then it comes to humidity and corrosion, right? So maybe it is for outdoor application. You are making, let's say, air quality monitoring system, okay, where you have put a sensor, then you have a IoT plugged in, or this device plugged in with an interface. So there, since it's an outdoor, right, you have to sometimes have a conformal coating also because of the humidity. So those sort of a thing you have to keep in mind. Then you have a EMI EMC. Let's say this hardware is going to get deployed near a high voltage system, or somewhere there is a lot of electromagnetic interference and all. So you have to have a proper shielding done, or proper protection done on the hardware itself, or on the schematic, or like in the, say, on the PCB itself. Then sometimes you need to have some certifications. So since here there is no requirement as a certification because we are doing internally, sometimes you will have ISO or UL or RoHS compliant reliability things to be done. So they are based on the standard requirement. You have to go read and understand what sort of a isolation, EMI filtering and other things is required. Okay, so this basically working environment helps in terms of selecting the BOM. Okay, and EBOM is mainly characterized into as an industrial or the commercial BOM. Okay, and or the automotive grade. So in terms of communication interface, right, in our requirement we have dual CAN. That means one of the DB9 connector we can use for dual CAN. The other can be used for powering it up, and there can be some interfaces that we can expose. To program the board, we can have a JTAG connector. So this is one of the image which I found on the internet, and I liked it because it talks about lot of interfaces. Okay, so if you see here, we have the JTAG connector. Okay, which we'll be having. Then you have to have the SD card slot, SIM slot, because we are using the GSM part. Maybe you want to have some sort of a USB UART with the GSM. Okay, so we can put that as well. And then what else? Okay, so I think once we go in the next video, right, where we structure the whole document for our hardware requirement, we'll be putting all the interfaces there. Now the thing is enclosure, right? So enclosure can be 3D printed. If you see here, right, so this is a 3D printed part. Okay, and this is also a 3D printed part. When it comes to something for the automotive, if you see, this is IP sort of a, so this is an IP sort of a thing. This is again a VCU sort of a design where you have a aluminum casting case with these connectors being done. So this is basically for the high-end automotive application. And whatever you see here, right, so these are basically GO OBD tracker which they are selling over Geo as a platform like Geo things. So here if you see, these connectors are for the OBD. So these are the standard for any vehicle you go and plug it, you will be able to have this interface. Okay, so it is up to us to decide. Maybe in your project you have specific requirement of a specific connector, and same goes for the, so we cannot go with something like this, right? Because we need to have an external antenna, you need to have some slot where you can insert the SD card, take that SD card out. So we need to figure out, maybe in the later part of this series I'll be designing something on the FreeCAD and showing you how you can have an enclosure done. Okay, so let's go back. So the third one, the second last one is the indicators. When it comes to indicators, right? So maybe on your hardware you need some sort of a heartbeat LED. Okay, whether it is powered on, whether it is connected to the server. Okay, so all these indications are visual indicators, where basically you can see a hardware and say, okay, yes, it is connected to the network. Yes, it has boot up. Okay, so all those things can be done on the indicator side. Now the final thing which we have is the cost target, which is very critical. So whenever you design or whenever you have a requirement of a hardware, BOM is very critical. So BOM basically is bill of material, and here we are talking about EBOM, which is electronics bill of material. So based on the set price, right? Let's say someone says you have to make something at $30. Okay, it cannot be you go for a high class component. So you have to see for compatible parts which are cheaper. Okay, yeah, but there is no sacrifice in terms of the performance. Maybe a brand thing is there. Sometimes you are getting something from TI, Texas Instrument, and the same can be done with a microchip. Same can be done with let's say some other company like MPS. So you have to decide based on your target cost. Okay, based on the end application, based on what life of that hardware you want to have. Okay, so lot of these things which you see, right, set a target cost. Okay, component selection is again dependent on the target cost. The obviously the automotive components will be costlier than the commercial or the industrial one. In terms of manufacturing, you have to see if in case something that can be done on a 2-layer PCB, don't go for a 4-layer PCB. It will add some cost to the PCB fabrication. And when it comes to layout, right, when you design the PCB, you might be placing all the components at the top. Okay, so basically whenever your feeder comes and you have the masking done, not the masking, basically during the assembly, right, the pick and place, right? So basically one side is where all your major components are there, right? On the bottom side there might be some minimal operations in terms of the component placement and soldering. Okay, so that might affect the cost. Okay, so you have to be very optimistic in terms of uh, what you are exactly planning, and things will come with experience. Okay, so you will be able to, you can refer to even few of the designs, open source designs from SparkFun, Adafruit, whatever you can find online, to understand ki how and what sort of maybe I think Adafruit has their projects already on EagleCAD, where you can just go and see how all routing has been done, how many parts has been placed on the top layer or the bottom layer. Those things you can go and check. Again, review and iterations, right? So whenever you design a hardware, this is nothing like a software where you go and you just go edit and run it, right? Here it's a time as a factor. So once you have a PCB fabrication done, you do a PCB assembling of all the SMT parts, okay, or the electronic components. So once you have that hardware and you figure out, okay, there is something critical you missed, okay, that cannot be sorted on that board, at least to have the testing done. So again you have to re-release the PCB Gerber. The PCB will come, then you populate, and then you test. So basically we are talking about close to 4 to 5 weeks of cycle. Okay, because it will take time to get the PCB fabrication done, again doing the PCBA part. So it becomes very critical. Whatever you are doing, make sure you are checking it thoroughly. And basically what I suggest, right, if in case you get that schematic reviewed from your peers or from your someone who has a better understanding, if in case you are just starting something on your own. Okay, so as a summary, if you see, we have to define a clear target, we have to balance component selection based on the performance and cost, and consider manufacturing volume and lead time to optimize the cost, and ensure the BOM is reliable, okay, compliant, and meets all the requirements. So now if we go right, so we talked about all the design goals what we have to do, okay.